Hello Neil, it's Chris from Phoenix Engine Management. Just a video of testing your Toyota Celsior 1UZ non-VVTi harness that we've rebuilt to be plug and play into an IS200. Alright, so as you can see, obviously fully heat shrinked up, all brand new wire, all rebuilt, and it is complete plug and play. So you can see your little patch resin that we reused, and then you've got your black and your grey and your blue plug in there, so everything just plugs straight in, nothing to worry about there. So what we're going to do today is we're going to go through all these tests. Now I have the ambient temp's not applicable in your case. You've got the older device before we started transmitting the temperature across. But we're going to look at your dash lights. We're going to go through the fuel pump, make sure that works. We're going to look at the speed sensor, reverse switch, temp gauge. Then we're going to start force feeding an RPM signal so we can get everything to work. And we're going to test the tach, the injectors, the coils, the idle air control valve, and obviously the starter. We'll test that as well as part of the fuel pump, and then we'll go through the trouble codes and how to read those. So I'm just trying to put more lighting on, so it's really dark now, so hopefully you can see when it all comes out. So to start off with, we're obviously going to switch the car on. So again, I've got a half cut here, so normal key as it is there. So looking in here, you can see the check engine light, so we know that the ECU is on and the dash has come alive. Now, the reason the temperature gauge is going all the way to hot, there's a default setting on the device that basically if the signal disappears or the sensor breaks or whatever, it's going to default and shoot all the way to hot. Now, it does plug into your single wire sensor. It is labeled temp, and it plugs into your single wire sensor that sits in the water bridge next to your coolant temp. Okay, so if I earth this out, because obviously the sensor gets an earth through the block, you'll see temperature gauge shoots down. Okay, so we know that that's working, so we're happy that the MPX is transmitting across. Now the other light we've got to test is the oil pressure. So what we're going to do now is we're going to, there's your oil plug, so obviously it is labeled oil. Okay, and we're just going to earth this out on the inlet manifold, and as you can see straight away, there's your low oil level light. Okay, so again, we're happy the device is transmitting MPX signals because that's transmitted via MPX. Now, the alternator charging light is automatically sensed by the device, i.e. what that means is if the voltage drops below 11.8 volts, then the alternator light will come on the dash. Okay, so now that we're happy with most of the dash light, or all of the dash lights, we're going to look at the fuel pump. Now, I do have a video on fuel pumps for Toyota and Lexus and how they work. So please feel free if you want, go watch that, and it goes into a lot more detail about it. But your ECU controls the fuel pump. So you can see we've got the ignition on. And what I've basically done is, this is the, sorry, it's coming over the top there, but these are the wires that go to the fuel pump in the car. So this is effectively replicating the fuel pump. I've got a little LED in here, and obviously this will light up when the fuel pump is supposed to be on. So that's going to show us straight away what it's doing there. So as per the other video, if you haven't watched it, basically the vehicle will not prime the fuel pump when you turn the ignition on. That's not how the system works. What it will do is it'll basically turn on the fuel pump when you're cranking, and it will keep the fuel pump running as long as the ECU's got an RPM signal from the crank sensor. Okay, so nice little test. If you don't get a fuel pump running and you got no spark, more than likely a issue with the crank sensor signal to the ECU. Okay, so what we're going to do now is we are effectively going to turn the key to start position. Once I do that, number one, you're going to see the starter solenoid. I've also put an LED in there so you can see that's your STA or starter. So that goes to your starter solenoid, and as I turn the key, a little LED comes on. Okay, so, and you can probably hear the relay clicking in the background. What I'm going to do now is I'm going to go to the fuel pump, and as I hit that, so there you go. So you can see as I hit the start, the ECU gets a starter signal and it turns on the fuel pump. Okay. So that's all that done. So what we're going to do now is we're going to go over to the speed sensor. So I've got my little device here, and this is going to imitate a signal for the speed sensor to work. And what I'm going to do is, here's your speed. There's your connector for that. Now on the speed sense, on this plug, pin 1 is 12 volts and pin 2 is ground. So I'm just going to connect that up. Sorry, you do it in the background. I'll show you in a second. Okay, and put it into test mode. Right, okay, so we're doing two things now. I know the 12 volts and ground is working because the device is turning on. And now what I'm going to do is force feed a signal to it. And as I do, or sorry, give a signal to it. Sorry, I'm going to try and block out the light a bit there. Okay, so we can see that that works, and that's coming directly from the plug. So we're quite happy that that's obviously working as it should do. Okay, so we'll just get rid of that. All right, so next up, we've got the reverse switch. So all we're basically going to do is, again, this is your gearbox harness that comes out the back. That is your reverse light, so that's going to plug into your gearbox. And we are just going to imitate exactly what your gearbox does. And we are going to just bridge the switch with this wire. And as we do, you can hear that annoying IS200 reverse buzzer sound. Okay, so we know that that works and we're happy with that. Just going to remove that wire because it's got 12 volts on it. Okay, so that's the reverse switch done. So now we're going to look at the temp gauge. Now I've shown you that when I earth it out, it does actually go down, so we're quite happy that it's getting a signal. But what I'm going to do now is I'm going to heat up the sensor itself. Okay. Put it see in the corner there. So I'm just going to heat the sensor up, and let's just have a quick look and see what temperature we're getting. Okay, so you can see it there. I'm going to heat it up a little bit more and put the blowtorch down so I can show you properly. Okay, it should be nice and warm and toasty. There you go. All right, so happy that works. In terms of that, because the 1UZ non-BBTI, we use an analog device, so it signals, it doesn't care what engine, what ECU is in it. So what we've done is we've made the water temperature adjustable. So in other words, if you're not using a sensor like that, if you're using a Nissan one, BMW one, whatever you're using, you're not limited to using that sensor. You can use whatever sensor you like. And I do have a video on how you go about adjusting that water temperature. Okay, so just look through all our videos and you'll find that one there. But what I normally do is let the car run. Now your radiator fans are actually controlled by a switch in the bottom of the rad, down at the bottom there, okay? So they will work irrespective of what's going on with the engine and the ECU. So once they're up to temperature and they come on and off a couple of times, the car should be up to operating temperature, and you can adjust the device to make the clock, make the water temperature accurate, let it read in the middle, okay? So what we're going to do now is we're going to feed a RPM signal to the crank sensor. That's going to activate everything up. So as you can see here, we've got a coil with a spark plug. Okay. And again, same on this side. We've got a coil here, spark plug there. So once I fire that up and give it a signal, both coils are going to fire. We're going to be able to see spark on the spark plugs. Then we're going to go one by one on each injector. And we're going to go through, and each one we're going to listen for the clicks to make sure it's working as it should be. So let's get this all up and running. So if you give me a second. Okay, let's put this into test mode. Okay, what's also going to happen, sorry I didn't mention it, is again, as you spoke about the fuel pump, once I feed an RPM signal, that is going to light up. All right, so that's another thing we're going to look for. Oh, and we're going to look for the tack on the dash. So we're going to go through all of that. Okay, so I'm just going to feed it crank sensor signal, and as you can see, that's now shot out to close the idle control valve. I'll just take it out quickly just so you can see. Okay, so we know the idle air control valve is working, and you can hear it in the background there. Give a signal to the crank cam. All right, so first of all, you can see the LED is on, so we know the fuel pump is working. We can see the spark on the spark plug on that side. We can see the spark plug on the spark on that side. So now what I'm going to do is we're going to go one by one. So this is obviously injector 1. And there you go. All right, injector 3. There you go. Injector 5. And injector 7. Okay, moving over to this side, we'll start on injector 2, which is this one. So that's clicking away. Then we're going to move over to injector 4. That's going all right. Injector 6. Okay, and injector 8. Fantastic. And last but not least, so there's your RPM signal working. So as you can see, because it's above 1000 RPM, that's obviously fully extending the piston in the idle control valve to block the hole, because it doesn't need to do that anymore. Okay, and what I'm going to do now is I'm going to kill the RPM signal, and what you're going to notice is the fuel pump will still keep running for a bit, and this happens when you turn the vehicle off as well. So I'll just do that. Coils have stopped working, fuel pump turns off. So don't be alarmed. When you turn the car off, the pump will still run for a few seconds. That is completely normal. That is exactly how Toyota did it. And as you can see, what the idle control valve has done now is it's pushed the piston all the way down, effectively opening the hole. So when you come next to start, it's ready to it's already fully open, so the air can get in and it can work from there. Okay, so a few things specific with your harness. Oh, let's go back here. Sorry, getting sidetracked here. So we've done tach, we've done injectors, we've done coils, we've done idle control valve, we've done the starter already, trouble codes. Okay, so I'm wondering if you're going to be able to see this now with the extra light. But first of all, previous to 2001, the IS200s had this diagnosis port. It's basically in front of this fuse box, next to the ECU box, but it's not present in 2001 onwards vehicles, okay? So, if you do have this, all you have to do is literally bridge E1 and TC. So if you have a look here, there's E1, there's very few terminals in there. So in this whole batch of 6, you've got this one at the bottom and this one here. Then you've got this cavity here. Then you've basically got 3 terminals, 1, 2, 3. It's the one in the middle. And so effectively what you're doing is you're bridging trouble codes, or what they call TC or trouble codes, or TE1. And you'll see the check engine light goes out and starts flashing codes. We've got 1, 1, 2, code 12. And that's 1, 1, 2, 3, 4. That's 14. Okay, we're not going to go through all of them. Okay, so in terms of the codes, they are in groups of 2. So basically what you're looking for is you'd have the 1 and the 4 is 14, and then the 1 and the 5 is 15, and then 3 and 1 is 31. So that's how you do them in groups of 2. When it gets to the end of the codes, you'll have an elongated break between the pauses, between the flashes, okay? That'll indicate to you that now it's got to the end of the codes, and it's going to go back again, and it's going to cycle through. So I always have a piece of pen and paper handy. I read all the codes, go from there. Okay, so that's how you read it on a 2001 model, or one of the 2 ways that you can read it. The other way is via your OBD2 port. Okay, so hopefully you can see this, but there's your OBD2 port, okay, in your vehicle. Now, this has TC in it as well, and that is basically pin 13, and pin 4 and 5 are on earth. So you can actually just bridge it between either 4 and 13 or 5 and 13, and that'll do exactly the same thing. Once you pull it out, you'll see the check engine light will go back to being solid again. All right. Actually, good tip for these non-BBTI ECUs, sometimes when the capacitors start to leak, one of the side effects, or one of the things that you can start to notice, is they won't give you any codes. So for instance, sometimes I tell people, unplug a coolant temp sensor or unplug a MAF. Try and check the codes like we've done there. If you unplug a MAF and you don't get a code 24 and 31, that could be an indication that your ECU has leaking capacitors and needs to be fixed. So that's just a little tip for you guys. Okay, right, moving on to the next little quirk of your harness. So as we discussed, you have a Toyota Celsior ECU. This is not a European or USDM LS400 ECU. So basically what you've got is, on the Japanese models, they came with a single wire oxygen sensor, not a 4-wire sensor like we got in Europe. Okay, so you see it's labeled O2 sensor. So what we've done for you, as discussed, is we put 4-pin DTM plugs on. So the reason we've done this is we've actually wired up all the wires that are relevant to a 4-wire sensor. So in the event that you need to replace your ECU, obviously finding a Japanese Celsior ECU is a lot more difficult than finding an LS400 one. So in the event that you do need to use a European or a USDM ECU, it's no problem, because we've already put all the wires in there. You can basically just cut off the plug of your 4-pin lambda sensor, and we can wire it all directly into here. And obviously that applies to both sides. So we've got the other O2 sensor there. Okay. The other one we've done for you as well is, you'll see on the alternator, basically the newer models, so sort of 92 onwards, all came with this, what I call the oval style alternator. It's a very common Toyota one. The very older Toyotas, things like 1Js, you know, very early 1Js, the 89 to 91 1UZ non-VVTIs, they came with these sort of round alternator plugs. So what we've done is we've put the oval one on, and we've got a little adapter to go here to the big round one. So in the event that you need to replace your alternator, okay, you've already got the oval plug. So you'd effectively just unplug this one and you can plug in a new one. You can put a 1UZ VVTI, 3UZ alternator on, no problems, and you're ready to go. So that's a nice one. And same with the starter motor. Yeah, what we've done is we've put the newer style plug on. So if you need to, the very old ones, and again, I'm not sure because I think your engine, you just got the harness and it could be a different engine, but in the event of that, there's just a female terminal in here. You can actually take that out, put a bit of heat shrink over and push it over to the older style starter. Keep the plug though, because that is a starter that'll work for anyone. So you can, again, if you need to replace it, you can get a starter motor from a larger range of vehicles. So again, anything from 92 all the way up to 3UZs, they all have the same starter and they use this plug. So it's much more beneficial to have that rather than to have the other one on. Okay, so I think that pretty much covers in terms of your harness, what you got to do. So in terms of when you get it to your side, you've got your main power cable. So this is your what I call your sub harness. So this goes to your knock sensors, as you can see here. So that's all brand new. That plugs in via a DTM plug at the back. Again, there's be photos at the end of the video so you can see the whole build process and what it looks like underneath. Then you've got your main power cable here that runs to your fuse box. Okay, this is then your terminal post for your alternator main positive. So you're going to run your alternator main thick cable all the way down along the subframe up to your alternator over here, and that's going to be where the bolt is. You're going to bolt that on. So effectively, you've got your main power starter cable that comes out the back here, that will go on there. You've got this coming to your fuse box, and you've got that going down to there. And in terms of earths, you've got the earth which runs underneath the battery, bolts to the chassis underneath, runs down, goes straight down there, and you just attach to the block at the bottom there. Okay, so that's the earth. And what I normally do as well is I actually utilize this earthing point over here, and I'll run an earth down to the cylinder head, and you'll see, I'll just show you here on my 3UZ. It's very similar. So you'll see you've got multiple holes at the back here on both cylinder heads. So you've got one that's going to be for the harness that comes out. So you've got loads of extra holes there, and you can just whack another earth on there from there. Let's get back into the light. Oops, I'm blocking. Okay, so I'm pretty sure that that's going to cover most things. Obviously, we'll send out the list of codes for you, so when you need to read codes, you can refer to it and it'll tell you exactly what it is. But in terms of that, we'll be putting the pictures up of exactly how it was built, the construction process, and how it looks complete on the table. And so that's it. So hopefully we'll get this in a box, get it off to you. And as you can see, it's really straightforward to install. Everything is labeled, so you should have no dramas there at all. We've obviously removed everything it's not necessary, but everything else is there. We do recommend, obviously, you recondition the motor if you're unsure of the history of it. Things like temperature sensors are obviously things that are sort of wary items, and usually you tend to find that they've not been replaced. You could usually tell by sort of crumbly plug, etc. All right. The temperature sensor is actually the same as an IS200, funnily enough. So if you've got a good IS200 sensor, swap it out in your motor, and that'll do the trick. Again, these are the single wire sensors that you get in there. I would say definitely worth replacing those, and you go from there. And then obviously just make sure you have all the correct igniters. So eagle-eyed amongst you would have noticed this is a blue sticker igniter. That's not for an early model. This is actually for a later model. So I've actually had to grind down the keyways on there. So what you'll notice with these sort of systems is the plugs are designed for the igniter. They have different keyways in. So in other words, you kind of can't put the wrong igniter on because the plug won't let you. You'd physically have to grind off a keyway to actually get it on, like I've done there. So it's a good little tip. If your plugs don't go onto your igniter, more than likely those are not the igniters for your harness. Okay, but that's it. We'll get this off to you, and hopefully it's a straightforward fit and you get it up and running. Thanks for watching, guys. Bye.